Okay, so again, dealing with radians. Radians is a concept you did learn last year. We're going to deal with it a whole lot more this year. And just a reminder that you pronounce this theta, not beta, not theta, theta. Okay. Unit circle. Okay. Why is a unit circle called a unit circle? What's special about it? It's a circle with units, not necessarily.
It's like a circle, but it's one.
Right, it's like a circle, but it's one unit. And what is it that's one unit? It is the radius. Now, 1 unit. What that 1 unit? 1 inch, 1 foot, 1 meter. It's 1 unit. 1 unit of measurement. All right. Are we good? Okay. Trip back to elementary school. Yes. Circumference equals, do you guys remember the formula?
Yeah, 2 pi r.
2 pi r. 2 pi r. All right. What was that?
No.
All right. Let's replace the radius with what our radius is in a unit circle. And what is it in a unit circle?
1.
So I'm going to have 2 pi times 1. And 1 is the multiplicative identity. You learned that back in elementary school as well. What does the multiplicative identity mean?
It's just itself.
When you multiply by it, it stays itself. So what's 2 pi times 1? 2 pi. All right, so that's what we're going to be using. Circumference is the length all the way around this circle, correct? If I make this circle with a piece of string, piece of yarn, and then I snipped it and laid it out, its measurement would be 2 pi. Does that make sense? All right. So let's draw our coordinate that we used on block day. And we learned, or we didn't learn, we reviewed then that this was 0, this up here was 90, this is 180, and this down here is 270. When you go all the way back around, it is 360. All right. Now, you learned this last year as well. Instead of using degrees as a measurement for your angles, you can also use radians as a measurement. All right. So this is still 0, but it's 0 radians. And we just talked about circumference going all the way around. Going all the way around would be what? 360 or what? 2 pi. 2 pi radians. I'm going to put rad for radians. Okay, so going all the way around is 2 pi. All right, so let's use that and figure out our, these are called quadrantals, the 90, 180, 270. Let's find those. I'm going to find this one first. Do you agree this would be half?
So it's pi.
So it's pi. Because half of 2 pi is pi, and like half of 360 is 180. Yes or no? Okay. Do you guys agree that 90 is half of 180? So what's half of pi? Pi over 2. All right. These are all radians. You just have to remember that because eventually we stop saying radians, we stop writing radians, but should you remember that it is a radian? Yes. All right. Anybody know what this one down here? Either remember or can figure it out? 3 pi over 2. Did you guys just remember that?
Yeah.
Okay. Another way to think of it is count by halves. This is 1 over 2, 2 over 2, 3 over 2, and 4 over 2. Let's do that again. 1 over 2, 2 over 2. Is 2 over 2 the same as 1? 3 over 2, and 4 over 2. Is that the same as 2? All right, so do you see how that pattern worked? Yes? All right. You will need to know that 180 degrees over pi radians equals what? What is it? 1. Good job. Do you remember that from last year, or you just figured it out right now? You figured it out right now? Okay, 180 over pi radians. If they are the same thing, will they reduce to 1? Yes? All right. Will it also work if I wrote it this way? Does it matter if I put pi radians over 180? Should it still equal 1? Yes. All right. We're going to use this like a conversion factor type thing. You guys use that in like chemistry? Yes. Eventually, we're going to use it in the beginning because we're taking baby steps in the first test. Eventually, you're going to start memorizing them and you won't need this anymore. All right. You can think of it when you were in elementary school and you learned your multiplication table and used to get those little multiplication charts, the facts. Remember you had to fill them in really fast?
Yeah.
Yes. And you got faster and faster as time went on, yes? And then you probably had a wall with the chart and got little stickers as you made progress. Same thing. As time goes, the more practice we get, the better you will become at memorizing them. Convert degrees to radians. All right, so we need to make sure we understand what we're coming from and what we're going to. All right, number 1, 90 degrees. 90 degrees is easy to do without any conversion factor here because we should know that 90 is the same as what? Pi over 2. But I still want to show you the math, so when we get to ones that are not as easy, we know how to do it. Are you ready? Here's how you think about it. You want to multiply by one of these. You want your answer to be a radian. So should the radian be in the denominator or in the numerator? Numerator. If I want my answer to be in radians, then I need that to be in the numerator. So pi radians over what? 180. Okay, so the degrees, you can think of the degrees as reducing. And can I reduce the 90 and the 180? Yes? 90 becomes 1 and 180 becomes 2, and I'm left with pi over 2 radians. Is that what we knew we would have ended up with originally? All right, so do you see how it works mathematically? No? Yes? Pi over 2 without the radians is fine. I will write radians now just to get us used to it, but eventually I won't. Okay, 30 degrees. Does anybody remember that one from last year?
Yeah.
What was it? Is it pi over 6? Do you guys remember? I heard one say pi over 6. Let's check it. All right. If I'm trying to end up with the radian, which one would I have? The 180 at the top or the pi radians at top? Pi radians in the numerator because I want my answer in radians and I want the degrees to cancel. Does 30 reduce with 180? 30 is 1, 180 is 6. So pi over 6 radians. Was he correct when he guessed the pi over 6? I shouldn't say guess because he knew. All right. Are we good? Number 3. Negative 120 degrees. Same thing. I'm still changing to radians. So what will I multiply by?
180 over
Pi radians over 180. Do you guys see that I'm still doing the same type of problem over and over? Yeah? All right. So think of the degrees as reducing. And does what 120 and 180 reduce? Yes? Cross out the zeros at the end. What goes into 12 and 18? 6. So negative 120 becomes negative 2, and 18 becomes 3. And what's a big mistake kids make? They do this. 2 pi over 3 radians. Where did I mess up? My negative. Please don't go so fast that you forget your negative signs. Questions on 1, 2, or 3? Number... Oh, I don't have a number 4. We have more notes, but it's in a different title. All right. All right. So I want to talk about ways to write this really quick. People will write negative 2 pi over 3 or negative 2/3 pi radians. Is that the same thing? Negative 2 pi over 3 or negative 2/3 pi? It is. It is. Why? Because I could put pi over 1, and if I multiply that, would I get negative 2 pi over 3? Yeah. So I can write it as negative 2/3 times pi. That's not a like 2 1/3 type thing. This is a multiplication. Negative 2/3 pi radians. All right, got it? All right. Now we're going to go the other way, and we're going to convert what? Good. Convert radians to degrees. All right, so degrees is what we're after now. So for after degrees, let me give you the first problem. Number 1, 4 pi over 3 radians. Now on this particular problem, I'm trying to get degrees as my answer. So where should the degrees be, the numerator or denominator? Numerator, because that makes sense. I want the radians to cross out. So I'm going to multiply by 180 degrees over pi radians. Do you guys remember doing this last year, yes or no?
Yes.
All right. What happens to the radians? The radians will always cross out. I will tell you right now, the pi's do not always cross out. You do not need a pi in your problem for it to be a radian. Kids freak out with that. Like, the pi's didn't reduce, oh no. It's fine. We'll see some in just a little bit. Okay, reduce. What about the 3 and the 180? Does that reduce as well?
Yeah.
All right. 1 and 3 goes into 180 how many times? What is 60? All right. So I'm left with 4 times 60, which equals what? 240. And is it radians or degrees? Degrees. Any questions? Okay. Number 2. Pi over 4, and I'm going to write this. Does that mean the same as radians? It does. You should know that. All right, before we do it, any guesses? 45. Remembered it, or you just figured it out from here? Remembered it? Does that make sense that if you cut pi over 2 in half, or if you cut 90 in half, you get 45? Pi over 2 cut in half is pi over 4. Yes or no? Yes? All right, we're going to just do the math just to make sure, see if we're doing it correctly. 180 over pi radians. I'm going to write it like this. Will the radians still cancel? Pi's cancel, and the 4 and the 180 reduce? Yes. What goes into, does 4 go into both of them? Yep, 4 is 1, and goes into 180 how many times? 45. So 45 degrees. Don't forget degrees. All right, questions? Okay, so this here is where kids struggle. Number 3, 1 radian. Okay, how do we know it's a radian? The R. Now, why do kids struggle? Because it has no pi. It does not need a pi for it to be a radian. 1 radian all by itself is still a radian. So I'm still going to multiply by the same thing, which is what? 180 over pi radians. Kids freak out. They're like, how do I know that's right? Because the radians are still going to reduce. Now, what's not going to reduce in this problem? The pi. And that there is where kids are like, oh no, I don't know what to do. Pi is just a number like any other number. Do you agree? Yeah, well, I mean, it goes on forever. It's an irrational number, but it's still a number, yes or no? Now, we round pi to what? 3.14. So, so I'm going to write this as 180 over 3.14. And I'm going to ask, I know you guys don't have calculators out right now, but I'm going to ask on homework when you do these that you do plug them in your calculator. I'll do it here. So that would be 180 divided by, I do have a pi key somewhere. All right. I will tell you this, if you do use the pi key versus 3.14, your decimal may be off just a little bit, but that's okay. All right, I get 57.295777951. Do you guys see that? Okay, I'm going to round that to 57 and round to the nearest tenths place, 0.3. So I'm going to put that this is approximately 57.3 degrees. Now, did you guys do that last year? Talk about what 1 radian was? No? Okay. If I had to round this to the nearest, guys, like 60, 70, 80. What would I round this to? 60. Do you agree that this is really close to 60 degrees? So should you make a mental note right now that 1 radian is approximately 60 degrees when it comes to graphing? Okay. Now, you will also see this on the test. 3R. Yes, it would be. The 3 threw me. All right. You're also going to see something like that with the 3R. There are 2 ways of doing it. Now I'm going to show you the one way we're going to do it together. Do you agree I can still do exactly what I did there? 180 over pi radians, reduce the radians, and then I have 3 times 180 divided by 3.14. Okay, so 3 times 180 divided by what? 3.14. And what do we get?
172.
If I were to round that to the nearest tenths, what would that become? 172. All right, can anybody tell me another way that might be a little easier? Instead of going through all this.
All that.
What was that?
All that.
Okay. All right. Not that this was hard. You're right. Compared to all the stuff we've been doing, all that, this is not hard. All right, but still even easier than this easy way.
Just no easier.
3 times 1 radian. What's 1 radian? 57.3 degrees. And if I do 3 times 57.3, do I get close?
Yeah.
Yep. This would be 171.9, and on the test, I would accept either one of those. Okay.
I'd rather do it the other way, safe.
Okay. So, yes.
So you just took the answer from the last one and multiplied it by 3.
Exactly. He said, did I just take this? Now, here's what you can do. So, on the test, they ask you to convert 5 radians. If you remember that 1 radian is 57.3, can you just multiply that by 5? Yes. Now, a few things. It requires you to remember this. Now, if you're like, oh, I'm not going to remember that, could you just resort to showing the work this way? Yeah. Regardless of which method you use, I need something, whether it's this work or this work. I need something. Don't just plug it in your calculator and get an answer. I need either this work or this work. All right. Got it? Okay, number 5, 3.2R. How do we know that's a radian? Okay, I'm going to let you guys do that one on your own. You choose which method you want to use. 180 over pi radians or times 57.3. All right, anybody have an answer? What do you have? 183.4. Anybody want to share how you did it?
Yeah, I'll share.
Okay, go ahead.
I times 57.3 by 3.2.
Okay, so you did it this way here?
The easy way.
The easy way, 3.2 times 57.3 degrees, and you got what?
183.4.
183.4. Did anybody do it this way? The pi, yes, okay. So you did 180 over pi radians. The radians cross out. You get 3.2 times 180 divided by 3.14. And did you plug it in your calculator?
Yeah.
Yeah, so 3.2 times 180 divided by 3.14.
I got 183.439.
Okay,
Yeah.
same answer? All right, any questions? Are we good? This stuff, did you guys do this last year? No? All right. Okay, next piece we're going to do is estimate. Yes, you did? Maybe, maybe not. Okay. Estimate in radians. Now, this is where knowing this is going to come in handy. So I'm going to put this one in red since we're going to need this one. in more than one place. We need to know that 1 radian is approximately 57.3 degrees. So when I give you something like this, first off, is that going in the positive direction or the negative direction?
Positive.
Positive. Now, would you say that's, we're in radians, would you say that's closer to 1 radian or closer to 2? 1. Why? Because 1 radian is approximately 57.3, and if we think of it as 60, what would 2 radians be?
120.
Is there any way that's 120 degrees? So your estimation would be 1 radian. And since there's no pi here, this one I would like you to write the radian, or the uppercase R, or rad. All right, number 2. All right, positive or negative? All right, do you agree if I put a line like right down here, that would be approximately negative 90?
Yeah.
Yes, and that's going further out than negative 90, yes?
Yeah.
So would that be closer to 1 radian, negative 1 radian, or negative 2 radians? Negative 2 radians. All right, do I need to explain that again? Yeah. All right, so radians, we need to, because it's all new to us, we're going to use this as our guide. So try to think of about how many 60s are there. Would there be 60? Would there be 120? Would there be 180? What does it look closer to? Does this look closer to 60 or to 120? 60, so that's 1 radian. Ignoring the negative business, does this look closer to 60 or closer to 120? Or closer to 180? Does it look like it could be 180? No. Does that make sense? So if this looks closer to 120, so 120 would be double this, which would be 2 radians. And since it's going in the negative direction, it's negative 2 radians. Okay. All right. So what did we use here? We used that piece of information there. All right. Questions here before we move on? Okay, this next piece we're going to do, it's really important. Even if you think like, oh, these are easy, I can do them in my head. It's really easy to at least attempt the way I'm about to show you, because we're going to be using this when we get to harder problems. Name the quadrant. Number 1, 3 pi over 4. Now, some of you probably can do this without, but again, I want you to just try this way, because when they get to harder fractions, it's easier if you know this method. Are you ready? Okay, first thing I do is I make everything have a denominator of 4. All right, and do you guys agree if I go all the way around, this would be 2 pi. What my numerator need to be so that when I divide it by 4, I get 2 pi? 8. Do you agree 8 pi over 4 is the same as 2 pi, yes or no? Okay, this is the halfway marker. So what's half of 8? 4. Do you agree that 4 pi over 4 is equivalent to pi, which is the correct spot? Okay, so this is the halfway marker from 4, so what's half of 4? 2. And if you were to reduce 2 pi over 4, what would you get? And is that the correct spot for pi over 2? All right. And after that, you can typically just count 2 over 4, 4 over 4. This would be 6 over 4 because they're counting by 2s. Do you see that? 2, 4, 6, 8. I know it. All right. Do you guys see it? So when you have this down, where would 3 pi over 4 lie? In quadrant 1, 2, 3, or 4? 2, because this is 4 over 4, 2 over 4, 3 over 4 would be within this quadrant here, so quadrant 2 is your answer. Does that make sense? Again, it may be easy to do without all those denominators, but it comes in handy knowing that tool. For something like this, pi over 7. Can anybody tell me that one without using any of the tools?
I want to say in the first class.
first quadrant. First quadrant is correct. When it's pi over 7, pi over 6, pi over 8, something like that, it's going to be first quadrant, but I just want to get us practice labeling it, especially when they're not even. So 7, what would the numerator need to be? So that when I reduce it, it's 2 pi. 14, I'm going to ignore the, actually no, I'll put them there, pi. Do you agree 14 pi over 7 is 2 pi? What's half of 14? And 7 pi over 7 is 1 pi. What's half of 7? So I'm just going to do that, 3.5 pi over 7. And you may not like the fraction and the decimal. It's not like I'm grading you on this. This is just to help us figure out where things go. So 3.5 and 3.5 is 7, yes or no? 7 and another 3.5 would be what? What is it? And let's just check it. This is always our double checker. What's 10.5 plus another 3.5? Did it work? Again, you're thinking, why am I doing all this? Because it comes in handy when we're working on these later on. I'm going to repeat what we did. We doubled it to get the 2 pi, cut it in half to get the 1 pi, cut in half to get the 90, and we realized that each quadrant was 3.5. 3.5 plus another 3.5 gave us this, plus another 3.5 gave us this, plus another 3.5 gave us that. Okay, now, does it still end up in quadrant 1 like we said it would? Yes or no?
Yeah.
Okay, so when you're doing homework tonight and they give you like pi over 8, should you do all this or just know it's quadrant 1? You should just know. We're doing this right now just to get the feel of what's going on. So if they gave you 9 pi over 7, what quadrant would it be in? In quadrant 3. Do you see how that would help? Questions? No? Yes?
If they give you like 3.5 pi over 7, what quadrant would that be?
They wouldn't give you that one. Yeah, but you could still you said, 3.5 pi? You would say 90 degrees or something like that. Yes, that they might do. Yes?
I'm confused on how that from the first quadrant.
So, say it again?
I'm confused on pi over 7 is in the first quadrant.
Because the first quadrant, and I should have put it here first, what technically, before I get to 2 pi, what is here? 0. Do you, I'm looking at my numerator, do you agree that 1 pi is in between 0 and 3.5? 0 over 7, 3.5 over 7. 1 would be in between 0 and 3.5.
What's the 180?
This here?
Yeah.
That's 7 pi over 7. Because 7 over 7 is 1 pi.
Okay.
Okay. All right, number 3, 6 pi over 5. Okay, we're going to do this one a little bit faster. Hopefully we've got the hang of it. And I'm going to put 0 this time, going all the way around. What are all my denominators going to be? 5. So what, I have to double it to make the 2 pi. What's the numerator going to be? 10. I'm not even going to put the pi's now. Do you agree that 10 over 5 is 2 and this is the place for 2 pi? What's half of 10? 5, and 5 over 5 is 1, and this is the place for 1 pi. Yes or no? What's half of 5? 2.5? Yes? Now, each 90 degree mark is 2.5. So 2.5 plus 2.5 is 5. Do you agree? What's 5 plus 2.5? And then what's 7.5 plus 2.5? What is it? 10. And is that back here where we started? All right, so this again is a double checker. Where does 6 lie? 6 would be what? Because this is between 5 and 7.5, so this would be quadrant 3. So if they asked you, where is 8 pi over 5, where would that be?
Quadrant 4.
Quadrant 4. Do you see that? Yes?
Yeah.
All right, questions on these before I move on? Okay, find 2 coterminal angles. Did we do this yesterday, finding coterminal angles? Yes. Yes. I will write it here, tonight's assignment. only because she has to leave. Tonight's assignment is page 261.
In the book, right?
Yes, and I'm going to put here that this is 3.2, and I'll get you guys your assignment sheets on Monday. Page 261. Get the right page down. Numbers 11 through 28. 47 through 54. 65, 66. And 83 to 86. Like last night, they're easy. Were last night's easy? Yeah. All right, so write this down, making sure I have it down correctly. Advanced math, yeah. All right, we're good? All right, I'm going to continue with the notes. Co-terminal angles, I want one positive and one negative. Did we do that on block day as well? All right. Do you guys remember on block day what we said and how to do it? We add and subtract 360. Here it is. We add and subtract 360. Do you guys remember that?
Yeah.
All right. Now the only difference is now we're no longer dealing with angles. I'm sorry, with degrees. We're dealing with radians. So we're still going to add and subtract, but now we're going to add and subtract what?
2 pi.
Good job. Add and subtract 2 pi. So same thing you did before, except 2 pi because we're dealing with radians instead of degrees. All right, number 1, pi over 3. So we're going to do pi over 3 plus 2 pi, and I'm going to put that over 1. Why is it a little more complicated tonight than it was on block day?
Because you have to find
Common denominators. On block day, or was it block day? Yes. On block day, it was just adding 360, which you could probably do in your head. This one, you have to find a common denominator. What is my common denominator here? So I multiply top and bottom by 3. What does that give me? 6 pi over 3. I add them together. What does that give me? 7 pi over 3. So if I were to plot and graph 7 pi over 3, its terminal side, I'd end up in the same spot as pi over 3. Does that make sense? All right. Now we're going to do the same thing, but we're going to do what instead? Subtract 2 pi. Do I need a common denominator again?
Yeah.
Did we already find it earlier? Can I just know it's 6 pi over 3? We should know that. Subtract, what do you get? Did I end up with 1 positive and 1 negative? Now, like on block day, if you subtract and you still end up with a positive, what do you have to do again? Subtract again until you get a negative. All right, questions on this before I move on? All right. Like block day, we're going to find complementary and supplementary angles. We're going to find complementary and supplementary angles. What's complementary? Angles in degrees, 90, and supplementary is 180. In radians, complementary would be pi over 2, and supplementary will be pi. Yes? All right. So, number 1, pi over 6 radians. I want you to think about what we did on block day, and I made sure to write it down so that we could use it today. When I gave you 65, how many of you guys just did that in your head and got 25? Yeah? I still wrote it down. I said, oh, what did you guys do? 90 minus 65 is 25. How did you get 115? You subtracted 65 from 180. So we're going to do the same thing here. First, to get the complementary, I'm going to subtract pi over 6 from what? From pi over 2. So it's like doing 90 minus pi over 6, but I'm doing pi over 2 minus pi over 6. Common denominator would be what? 6. This fraction would become what when I multiply top and bottom? 3 pi, and this one would become, or stay, pi? Subtract, what do you get? And yes, reduce when you can. Does 2 pi over 6 reduce? Pi over 3. Do any of you guys remember from last year what pi over 6 was in degrees? 30. And pi over 3 was, and what's 60 plus 30? Does it make sense?
Yep.
All right, good job. All right. Oh, forgot the supplementary. This here was the complementary. Now we're going to do the supplementary. So instead of subtracting from pi over 2, I'm subtracting from pi. And I wrote that one down wrong. Pi over 6 subtracted from pi. That's an easy common denominator. What's pi going to become? 6 pi over 6. Does that make sense? 6 over 6 is the same as 1. Subtract, what do you get? 5 pi over 6. Now that's an easy one to add because they have the same denominator. What's 5 pi over 6 plus pi over 6? 6 pi over 6, which is pi, which is 180. Does that make sense? All right. This next one is the one, or the tricky ones that kids stumble on. 1R. What's 1R mean? 1 radian. Okay. So complementary. We're going to subtract 1 radian from what? Pi over 2. Can I do that? Are those like terms? Can I subtract them? They're both radians. This is still a radian and that is still a radian. I can subtract, but I need to change that to a decimal. Pi over 2 is equivalent to what? How do I figure it out? 3.14 divided by 2. So you do 3.14 divided by 2. 3.14 divided by 2 is 1.57. What was it? 1.57 minus 1, and these are both radians. What does that equal? 0.57. So 0.57 R. Got it? And I will at least set it up because the bell's almost going to ring. This is complementary. Don't pack up. How do you do supplementary? You subtract 1 radian from what? From pi. 3.14 radian minus 1 radian is what? 2.14 radians. Did anybody not like those as much? Yeah, a little more confusing. Make sure you have the assignment written down. Yes.
If we didn't add all of them, is this still?
No, on these I would like the R's because there's when you have like 2 pi over 3, you can tell it's a radian. But these are a little harder. So on these I definitely would like the R.